Okay, for this question, we have a box with square base and open top, and we must have the volume to be 32,000, and we're going to find out the dimension of the box so that we can minimize the amount of material used. In other words, we have to minimize the surface area. So now, let's go ahead and put down what we know. I will draw a picture for you guys. We have a square base box, right? So I will just draw a 3D picture like this. And let me just put down a 3D picture like this, right? Okay, first of all, because we know that this is a square base, so that this right here, since I don't know, I'll just put down x. And that will also mean that this right here will also be x. However, the height of the box, it's not necessarily going to be x, because it's not cube. I don't know yet, right? So I'll just put down y right there, right? So, as we can see, based on this, the volume is just x times y, which is x squared times y. And we know the volume has to be that, so it has to be 32,000 right here. Now, let's go ahead and put down what we want to know. We want to find out the minimum, right? So, let's go ahead and write that down. The amount of material used, so we have to look for the surface area. We want the minimum of the, I'll just put down A for the surface area, right? First of all, just look at this picture, and I will actually just do some dashed lines like this, so you can see. First of all, right here we have the base. This right here, it's the square. So we must have x squared. That's the area for the base. And then, if we look at the side, this is a rectangle, and the area right here is just x times y. And in fact, we actually have 4 of this, because we have one right here, another one right here, and then another one right here, and then another one right there, for 4 sides. So we have to add 4 times xy. Each one, the area is xy, 4 of them, so we have to add this. Well, as we can see, we have y right here, so let's go back to what we know. We can divide the x squared on both sides. In other words, y equals 32,000 over x squared. And then put this right there. And we will get the area in terms of just x, so a of x, and this is x squared plus 4x times the y is just that, namely 32,000 over x squared, like this. Very nice. And of course, we can simplify this a little bit. X and x squared, and then 4 times that, right? But I'll write it down right here. All right, so our area is going to be x squared, and plus this times that, which is going to be 128,000, right? So plus 128,000 divided by, we have one more x on the bottom, right here. And then, of course, we have to find the minimum of this, so go ahead and do our derivative. Here we go, a prime of x. Differentiating this, we get 2x, and then differentiating this, do not use the quotient rule, because if you put the x to the top and then look at this as x to the negative 1 power, it's easier. So bring the negative 1 to the front, so we have negative, and then 128,000 over x to the negative 1 power, and then minus 1 because of the power rule. So we have x to the second power on the bottom like this. So that's our derivative. And then, as usual, we are going to set this to be 0, and then we just have to go ahead and solve this. This time, though, it might be slightly trickier to see how we should actually solve for x right here. But as usual, we should try to combine and try to factor, so I will do that. With that said, let me multiply this by x squared and also x squared. So we can see this is 2x cubed minus 128,000 over x squared, and it has to be equal to 0. And again, this is for the a prime, right? And first of all, let me just factor out 2. So we have 2, and then we have x cubed minus, in fact, here is 64,000, and then all over x squared, and that's equal to 0, like this. In fact, we can factor this, so already as x cubed, and then minus 64,000 is the same as 40 to the third power. So to factor this, difference of 2 cubes, we will get x minus 40, and then times this square, which is going to give us x squared, and then we add just this times that, which is going to be 40x, and then we add this square. 40 squared is 1600, so that's all we have. And again, if you really want to just solve for x from here, in fact, it's fine too, because we just need to find out one critical number that will make us, that will solve the equation for us in this case. Anyway, in fact, this is going to be this is never going to be 0, so we just have to worry about that. So we can see that the critical number is actually just x equals 40, like this, right? And then go ahead and do the sign chart real quick, a prime, right, for this, which is this expression. Well, when x is 40, let's see, pick 1 maybe. So negative, positive, positive. So altogether is negative. And then pick a number bigger than 40 and you get positive. Yeah? So yeah. And imagine if this is like a general function, in fact, you also have to care about when x is equal to 0. So just be really careful with that. And in this case, we don't really need to worry about the 0. Because right here, when x is 40, and we know a prime goes from negative to positive, that means we actually have a minimum, right? So we know x is equal to 40, that means y, which is that 32,000 over x squared. And because x is 40, so we know y is equal to 32,000 over 40 squared. Work that out, you'll get 20, right? So this is how we are going to answer the question. I will just put down right here. Yeah, so I'll just answer it like this. And that's it.